What's up, coders? Today we are going to cover logistic regression, in which first we are covering the theory of logistic regression. Then we are covering our actual implementation of logistic regression, and third we are making a machine learning model which can predict the given email is ham or spam. So let's get into it. For introduction of logistic regression, so logistic regression is basically machine learning algorithm which we are using for primary the classification one. The name regression doesn't mean that it is a regressional model. We are primarily using it for prediction because it does uses log loss etc. So let's get into it now. The why don't we just use the linear regression for predictions? Some of you might get question that we are just using the machine learning model which is linear regression. If the regressional score is that greater than the threshold of 0.5, then we can consider the category as a ham or bad category or whatever it may be. Or if the score is below that threshold of 0.5, then we are covering that considering it as not spam or not risky. So it is not like that. Sometimes linear regression got the score which is beyond 1, but as you know that probability is also lies between is must be lies between 0 and 1. It must not exceed 1 or it not exceed or beyond exceed the 0. So using linear regression is bad practice because linear regression might give us value greater than 1. So we are using logistic regression. So logistic regression is basically modified form of linear regression having sigmoid function to control the values or to change the values between 0 and 1. Between 0 and 1 means that the formula for the logistic regression is that linear regression plus sigmoid function. So what is the sigmoid function is actually? The sigmoid function is the function with which we are converting every value of linear regression. Means what we have as a linear regression, z is equals to that is coefficient into input plus that intercept. Means in simple words, linear regression z or y is equals to b0 plus c into m. So but the sigmoid function having formula e is equals to 1 upon 1 plus e raised to minus z. When we pass each value of y or z into that sigmoid function, this function simply converts into the value which is between 0 to 1. So that's why we are using it as a classification algorithm to predict the probability of each possibility or each feature that we have. So that's all about sigmoid function and why we are using the logistic regression instead of linear regression for probability discussion or classification. So let's get into it. Hope I am audible to you. As we have covered previously the topics about the logistic regression, but the couple of topics are left. Let's get through it. So first, as you all know that the linear regression uses the mean squared error as the loss function, but what does the logistic regression uses? So the logistic regression uses log loss, which is called as the binary cross entropy. So the name binary cross entropy, just don't be scared of it. It is simply a loss function. We can use the linear like mean squared error as a loss function, but the log loss are having the log terms, which is more suitable or more reliable, like kind of the ideal one for the logistic regression. So that's all the that's what we are using the log loss function for logistic regression. But the thing is that why do we call it as the logistic regression for the idea is actually that the sigmoid function is also called as logistic function. That's why we are seeing it as a logistic regression. So logistic regression is a simply linear regression with sigmoid function. Sigmoid function just converts its value between 0 to 1, which having the formula 1 upon 1 plus e raised to minus z. Z is the linear regression's prediction or the formula of it. So let's come to the actual point, log loss. So log loss or binary cross entropy having formula minus of y into log of p plus 1 minus y into log of 1 minus p. Y means the actual prediction, the actual class, whether it is the ham or spam it may be, and the p means the prediction, which is the having the numerical value between 0 to 1. So if the probability is high, then the loss is small. If the probability is low, very less, then the loss is huge. So now okay, so this is how the sigmoid function looks like. It does looks like a S in English alphabets, having values between 0 to 1, as you can see, and the formula of it is 1 upon 1 plus minus e raised to minus z. Now, so as third part that I have talked to you about, we are actually making an model to predict the given email is the ham or the spam one. So for that reason, I have one question for you. So listen to that question. If we have the categories which are red, green, blue, then how do we encode it? We can simply use the label encoder, or in some cases we are using the ordinal encoder. But what if we have different strings as different features or different observations having different strings? Then how do we can encode it? So to encode it, we does require the vectorizer, which is also what it does is actually converts the string into the numbers or the importance score, in which let's take it an example. Suppose we have to make an model which can predict the given email is ham or it is a spam one. So let's get into it. Suppose we have to create a model to predict the email is ham or spam. Main problem is that how does the model can understand the text? Okay, model don't understand text, it does understand numbers only. There comes the text dot vectorization. Means text vectorization means we are converting text into numbers. One of the most easiest technique is TF IDF, which is TF IDF. TF IDF, what it does give the score of importance for some words like free, lottery, win. They might become the importance feature for spam detection. For words is the name or some common words, the importance score is normal. Means the TF IDF vectorizer, which converts or gives the numbers for the particular words in a string, so that the score of importance will show the given email might be ham or spam. So let's get into it. For that reason, I have one directory which is called as machine learning, and in datasets I have emails.dataset. In emails.dataset we have 1000. Wait a minute, let's out zoom a bit. So we have 1000 emails. It is 2000 though. Yeah, it is 2000. We have 2000 emails. Each row or each observation is one email with the target, which is in red font here. It is the ham, or like it is a spam or ham or spam, etc. So let's get into it. Just copying that path, copy as path, and running the VS Code. VS Code, we are using Jupyter Notebook. It may take a while though. Okay, let's get into desktop with the machine learning, and just made a new Python notebook here. Import pandas as PD. Data frame is equal to pandas dot read CSV and data frame. So we have two features, which is email and label. In email we does have emails, and in label we have categories, whether it is ham or it is spam. So let's split it into X and Y. For X we have data frame of email, and for Y we have actually before splitting it, actually we does have to encode the category of that label, because it doesn't, the model don't understand the ham or spam, etc. So for that reason, just from Scikit-learn dot preprocessing import label encoder. L should be capital here. Yes, sorry, label encoder. So making an instance which is LE for label encoder. So now data frame of label is equals to LE dot label dot fit transform data frame of label, I guess. Then what does, okay, now we have converted label and email. Label is into string, which is, sorry, label into zeros and one. Just inverse transform LE dot inverse transform what is what, so 0 comma 1. Method is not stable. Inverse transform, I may get a typo here, no worries at all, we will definitely look for it. So now we have encoded it. Let's split into x and y though. So x is equal to data frame of email, and y is equals to data frame of label. So now we have split the data frame into x and y. Just now we are splitting it into train and test split. For that reason, from Scikit-learn dot model selection import train and test split. So x train comma x test and y train comma y test is equal to train and test split of x y with test size of 0.2. With test size 0.2. Now let's check the length of y test. Okay, perfect. So now we have split the data set into x and training and testing for with a margin of 0.2. And now let's tf idf the email column. So for that reason, x train tf idf is equals to, for that reason we are going to require the vectorizer, which is from Scikit-learn dot Scikit-learn, I get a typo, Scikit-learn dot feature featu feature extractions dot text import t should be capital, tf idf v should be capital, vectorizer, making instances vectorizer is equal to t capital tf idf vectorizer with parenthesis. So now we have made the instances of that vectorizer. Now x train tf idf is equals to vectorizer dot fit transform x train x test t tf idf is equals to vectorizer dot transform x test. Now we have train and test splits of tf idf. Okay, then we have to select the model from Scikit-learn dot linear model import for the logistic regression logistic regression. Then like in a model instances, that model is equals to logistic regression. Okay, and now we have made instances of it. Just fit the model on it. Model dot fit. We are providing x train tf idf with y train tran. Okay, now we have fitted the model. Let's check the accuracy of it. With x test tf idf y test. So accuracy is here 1. Let's check whether it is giving the ham email, ham score, or spam score. Let's check. It is like the final boss examination of our model. So make object is equals to first we have observation, which is obvious is equals to you can win up to 100k, join today, get deals. So this is what email I have prepared as observation. Now observation is equal to obs dot vectorizer dot obs dot not actually scalar is vectorizer dot. How do we can use the vectorizer here? Vectorizer of observation, I guess. No. Vectorizer dot obs, I guess. No, obs has no. So how do we can use the observation here? Observation equal to vectorizer of vectorizer. How do we can use? Let's chat GPT a bit. How do I can make a observation by my own scaled with scalar? Just using the example. What heck is doing here? Vectorize. This is equal to vectorizer of obs, I guess. No. Let's push the screenshot here. Time is running. How to make it hurry? Yeah, I got it. So it says just a silly mistake from my side, forgive me. So observation is equals to vectorizer dot transform and then obs. Sorry guys. So we have vectorized that observation. Now let's see what model can predict. Model dot predict that observation. So model have given array, then LA dot inverse transform that 0 ham. So ham observation is ham. So ham means not spam. What the model is going to the accuracy is not the actual accuracy, guys. It is all up to vectorizer. So if vectorizer don't give any ham score to that the string over here, then we just not getting an error. It is up to vectorizer for such applications of that model. Let's check for what we can make is win 100k. Then what we can add as a spam, hurry up, I guess. It is still ham because it is not seeing like a spam though. Then what does the spam look like? Let's seek into a model which is spam. The word free is coming in the spam category, guys. let's use that word, which is free mobile, I guess. Mobile on today. Let's check what it does. Okay, then we have one here. So what does one indicates here? It does indicate the spam, means the vectorizer has catched the word free. When we use free, or it got free in HTML, or the word is indicated, then the model or vectorizer is simply going to consider as a spam. So this is because I have switched in the dataset from Claude. But this is not actual the dataset, it is artificial dataset. If we got an actual dataset, then we can got the accuracy or the actual performance that we are that we are aiming for. As this is an artificial dataset, we don't got that much accuracy, but it is up to vectorizer and the database. But the overall idea is that just we have to import that CSV, then encode that category as ham or spam to numerical structure, that 0 or 1. Then then we have to split it into X and Y, then split and training test split. Then have to import an vectorizer. You may go with another vectorizers if you want to, but TF-IDF is the most common vectorizer that we have. That's why we have chosen it. So there are so many vectorizers. I guess like Gaussian bias, etc. Can also provide the vectorizers, but this is confirmed that. Then make the TF-IDF instances of that X training and test. Then import and like choose a model like a logistic regression, which I have chosen. Then fit the model on the instances of training and testing. Training. Then check the score for the testing, which is score of 1 means going well, don't worry at all. Then check for observations. Then the third part, which you might not consider but which is important, just import the job lib here. Then job lib dot dump. Just we are just saving those model so that we can like implant it or more. Just like what do we say for that? Just combine with an application, so that we have made an application for the email category detection or the classification one. Okay, to make that application, sorry just for my bad English, to make that application we are going to require that like model. So we have just saving the model so that we can call it up there. So joblib dot dump the model with the name logistic email dot pickle, and the scalar as joblib dot dump with vectorizer here, not scalar. Vectorizer as vectorizer dot pickle. Okay, so that's done. Let's check up here. In machine learning, we have both the logistic regression, this model, and the vectorizer as pickle format, so that we can use them where we want. So thank you for watching the video. Keep supporting, guys. Thank you, guys.